So in our previous section, we discussed about the ingress replication using BGP, or basically we were doing the intra-subnet communication. At the end of the video, we discussed that the intra-subnet communication can be easily achieved using multicast, and we do not need to configure the BGP EVPN. So in this particular section, we are going to discuss how we can leverage multicast to for our host to communicate into the same subnet. Okay, so as I mentioned, you can see here the bum traffic handling, or basically the broadcast, unknown unicast, and multicast traffic, or in other words, the intra-subnet communication. So this particular method is also known as the flood and learn method. So we'll see how this can be achieved. So each VNI will be a part of particular multicast group. Okay, so if a leaf switch or a VTAP receives any bum traffic that is originated in a particular VNI, then uh, the leaf switch is going to send the particular bum traffic to all the devices which are part of that multicast group. Okay, you can see here an example that, let's say we have VLAN 10 with VNI 10 10 10. It is a part of, let's say, multicast group 224.10.10.10. Then you have VLAN 20, which is in VNI 20 20 20. It is having the multicast group 224.20.20.20. So now any bump traffic, if it's at the leaf for VLAN 10, then using the multicast tree, it will be sent to all the leaf switches that are part of that multicast group. Okay. So the leaf will make sure that the said flooded will not go on the ports it received the ARP request. Okay. So that is pretty straightforward. So it is not going to send the bump traffic on the port that it received the ARP request when, if we talk about the communication at the very beginning. So as soon as your VTAPs comes online, the multicast group that we have configured under the VNI, so the IGMP join message will be sent to inform the upstream device. In our case, it is the spine switch, that I am interested uh, in the traffic for this particular multicast group. Okay. In the last point, I mentioned that now in the destination IP or the outer IP header, there will be the multicast IP address of the VNI, and the destination MAC in the outer header or outer layer 2 header. That will be the multicast MAC address that will be derived from the multicast IP. And all this will happen for the during the first communication, because later the traffic will go unicast. It is pretty straightforward, right? Each VNI maintains its own separate MAC table. This also we have seen in our previous videos, wherein we can check this particular thing using the commands like show MAC address table and then VNI number, right? So the advantage of VNI and multicast group one-to-one mapping. See, in our previous slide, we have seen that we are creating the multicast group for each VNI, so that VLAN 10 traffic will be flooded into VLAN 10 only, and VLAN 20 traffic or bump traffic will be flooded in VLAN 20 VNI only. Okay. So the advantage of this is that we discussed that bump traffic will be controlled and it will be received by leaves that are owning that particular VNI. But the disadvantage, there is one downside to this particular approach, because see, if we have a large setup and we are using thousands of VLANs, and each VLAN they'll be part of a particular VNI, right? So then there will be too many multicast entries that need to be maintained by our devices. right? So there could be the software or hardware limitations also. So what we can do, we can use the same multicast group for all the VNIs. Okay. So now you may think that what happens if, let's say, I'm in VLAN 10 and or let's say VNI 10 10 10. I'm a part of a multicast group, and on another device which is having VLAN 20, and that is a part of VNI, let's say 20 20 20, but it is also configured with the same multicast group. So if the leaf switch receives in the bum traffic in VLAN 10 or VNI 10 10 10, then using the multicast tree, the that particular bum traffic will also be received by the other leaf switch, which is not having VLAN 10, right? Instead, it is having VLAN 20, but because it is a part of same multicast group, it is also going to receive the traffic, but it is not a problem, right? Because what exactly is the thing is that once the other device it receives the bum traffic, because in the VXLAN packet or VXLAN header, it will be containing the VNI 10 10 10, and if it does not have the VNI 10 10 10 configured, then it is going to silently drop the traffic. But in this way, this is one of the efficient way, because if we use the one-to-one mapping for the multicast group and the VNI, then there will be lot many entries that a device has to maintain. And in your see this one-to-one mapping, it can be beneficial if you have small network, but for large network, it is recommended to use the same multicast group. So let's see the practical. So now let's see it with the practical. So we have spine 1, leaf 3, leaf 4, and leaf 5. In our example, we'll work on spine 1, leaf 3, and leaf 5. So first of all, we need to enable PIM on all the devices. So let's start with the spine switch. So we need to see in our previous example what we had done. We were working on the BGP. First of all, let's remove the BGP configuration. If I do a show run interface NVE1, there is no configuration on leaf 3, so that is fine. If I go to leaf 5, we can see show run interface NVE1. So we can remove the BGP related configuration, right? I will say no host reachability protocol BGP. So it is asking us to remove the replication command. So I will say member VNI this. I'll say no ingress replication protocol BGP. Similarly for VNI 20 I will say no ingress replication protocol BGP. I will say exit, and I will say no host reachability protocol BGP. Now if I do a show run interface NVE1, so now we do not have anything, right, under the NVI interface, and we are going to configure now the multicast. Okay, so let's start with the spine switch. So we'll say feature PIM, and on all the interfaces we are going to enable PIM, so including the loopback interface. So if I go here, so we have loopback interface 0, and Ethernet 1 by 1 is going to leave 3, and Ethernet 1 by 3 it is going to leave 5. So I will say interface loopback 0, let's say IP PIM sparse mode. Then we have interface Ethernet 1 by 1 IP PIM sparse mode, Ethernet 1 by 3 IP PIM sparse mode. Now if I do a show CLI history unformatted by last, let's say 5, or let's say 8, last 8 commands. Let's take 10. So I'll copy on this one, and for leaf 3 and leaf 5 both we have Ethernet 1 by 1 which is connected to spine 1, so we can copy till Ethernet 1 by 1. I'll go to leaf 5, I'll paste it. Similarly, I'll paste the configuration on leaf 3 also. If I do a show IP PIM neighbors, now you can see that we have the PIM neighbor, or which is the IP address of our spine, right? If I do a show IP mroute, so far we did not define any multicast group, right? So let's check on leaf 3 also. If I do a show IP PIM neighbor, so now leaf 3 is also having one PIM neighbor which is spine 1. You can see that this is the IP address of spine 1. Now what we can do, we can consider that spine 1 is our RP, or the rendezvous point, wherein the source or the receiver, they both register themselves. Okay, so the traffic will pass through the RP. Okay, so we will follow the simple multicasting here, and we will configure static rendezvous point on our leaf switches. So I will just say IP PIM, and then I will say RP address, and we can say the RP address for the spine is 111, and then we can define the group list, maybe let's say for any multicast IP we can use 1.1.1.1 as our RP. So we can configure this, or we have to configure this particular command on all of our devices. So I'll configure it on leaf 5 and as well as on spine switch. On your leaf switches, now you can also verify. If I do a show IP PIM RP, you can see that we have the RP which is having the IP address 1.1.1.1. Okay, and for the group range 224.0.0.0/4. So for all of the multicast range, we have this RP configured. You can verify the same on leaf 3 also. So we have the rendezvous point 11111 for this particular multicast range. Now you can also check show IP M route. Can see we don't have much in the M route table because so far under the NVI interface we did not configure any multicast. Okay, so now let's start configuring the multicast under the NVI. If I do a show run interface NVE1, then nothing is there. I'll say interface NVE1, then I will say member source interface loopback 0. I will say member VNI 10 and I will say multicast group, let's say 224.10.10.10. I will say no shut, show run interface NVE1. Simple configuration, right? So now for the VNI 10 we configured the multicast group. Okay, so now if you check the show IP M route, now you can see that now we have entry for this particular uh, multicast group, right? It says star comma G entry for basically it is any source multicast, right? And we're using the NVE interface. For the incoming interface is Ethernet 1x1, which is connected to your spine switch, right? And it also has the S comma G entry, which is this is the IP address of leaf 3 itself and the group address, right? So now if I go to, or we can do a similar configuration, show run interface NVE1, we can copy it, can go to leaf 5, show run interface NVE1, we can say interface NVE1 no member ENI 2020 and I will just paste it. Show run interface NVE1, simple configuration, interface NVE no shutdown, source interface will be loopback 0, member VNI VLAN 10. This is the multicast group. Show IPM route. Now we have the entry, the star comma G entry for this particular group, and we have the S comma G entry for itself, right? Now, just give me one moment. Okay, so the multicast is already configured and we have also configured it under the NVA interface. Now you can also do a ping test to see if our multicast is working properly. Till leaf 3 you can say ping multicast and the multicast address interface Ethernet 1x1 which is going to the spine switch. And now you can see that we are getting a reply from 13.1.1.3 which is leaf 3. So our multicast is working properly. Now let's try if we are able to ping from host 1 to host 5. So first of all let's go to leaf 3. Okay, so first of all let's go to leaf 3 and see if interface 1/3 is up or not. No, it is not up. So I will say interface Ethernet 1/3 shut, no shut. Show interface Ethernet 1/3. Now interface is up. If I do a show run interface 1/3, we have simple configuration. It is into VLAN 10. Likewise, I will go to leaf 5. I will say show run interface Ethernet 1/3. It is also in VLAN 10. If I do a show interface Ethernet 1/3, it is showing up. Okay. Now if I go to host 1, which is having IP, if I do a show ARP, it is having its own IP address only. So now let's try to ping from 10.1.1.3. So before we ping, let's also capture the interface. Just first allow me 2 minutes. 192, 168. So let's capture the interface Ethernet one by one. This is on leaf 3, and also let's capture Ethernet one by one on leaf 5. Let's wait. So this is leaf 5. You can see the multicast messages going through. Okay, so now let's try to ping from host 1 to host 2. If I go to leaf 3, you can see show MAC address table. We don't have the information about the uh, hosts that are residing on another leaf switch, right? Even we do not have information about the host 1 at leaf 3, or if you go to host 5 or maybe leaf 5, if you do a show MAC address table, we do not have any entry for uh, the remote host, right? Only 5, though we have the entry for host 5, but it does not have any entry for leaf 3 host or host number 1, which is having the MAC address of 1111, right? So now let's try to ping from host 1 to host 2, or sorry, host 1 to host 5. Now you can see that we are able to ping properly from host 1 to host 5. Also, you know that we are not using any BGP, etc. We are just using plain multicast in the underlay, right? And we are able to ping from host 1 to host 5 if I stop this. So this was leaf 3 interface. Now you can see that I'm checking for the, you can see we have the R broadcast message, right? It is asking that who has 10.1.1.5 tell 10.1.1.3, right? So basically we have the ARP broadcast, you can see here, right? In the ARP packet we have the source IP, which is the host 1 IP. We have the target IP, which is the IP of host 5. The source MAC is the MAC address of uh, host 1. Target MAC it is trying to resolve, right? The opcode request, or the opcode is 1 because this is the ARP request. For ARP reply, the opcode will be 2. Then the ARP request will be, see in our previous section also, you remember that we discussed about the packet flow. Now you can see here also the packet walk, how the inner layer to header is working, how the VXLAN is, okay. So the this is the payload. Then we have the inner source MAC and inner destination MAC. So because we are working into the same subnet, you can see that the inner source MAC address is 1111, which is the host 1 MAC address, and the destination MAC is the broadcast. In the VXLAN, you can see we have the L2 VNI information, or the VNI for 10, 10, 10, 10. Then we have the UDP header, wherein we have a random source port and destination port for VXLAN it is using 4789. Then we have the outer IP header. In the outer IP header, the source IP is 3333, which is the leaf 3 loopback IP. And destination IP, as we mentioned in our slides also, that the destination IP will be the multicast IP address. In the outer Ethernet source MAC address, you can see that we have the MAC address of exit interface. You can see, as we discussed in our previous packet flow also, that it will here the simple layer 3 device logic will be applied. So the source MAC will be the exit interface MAC, and the destination MAC will be the next hop MAC address or the spine interface MAC. So similarly, you can see here the source MAC is the 3131. If I go to the diagram, you can see 3131 is the exit interface MAC of leaf 3, and 0011 is the spine 1 interface MAC, right? But in this case, what will be, as we discussed in our slide also, because we are using the multicast MAC address, right? Or in the destination IP, we are using in the outer IP header, you can see in the destination, we are using the destination IP. So the destination MAC will be derived from this destination IP, and in the outer MAC header, the destination MAC will be the multicast MAC address. Okay, now we can see you can see the RP reply, right? So RP reply is always what it is. It will be unicasted, right? So we have the RP reply. The opcode is 2. We have the sender's MAC, which is host 5 MAC. Sender IP host 5 IP. Target IP is the target MAC is the host 1 MAC address. Target IP is host 1 IP address. Then you can see here the inner source and destination MAC. It is the source MAC is the host 5 MAC, destination MAC is the host 1 MAC address. Then you have the VXLAN header with the VNI information 10.10.10. We have the UDP header wherein we have the source port as random 55313, destination port is fixed 4789, which is for VXLAN. In the outer IP header, we have the source IP 555, destination is 333. Similarly, in the outer Ethernet header, source MAC is the MAC address of, you can see, because now we are in the reply packet, there is no multicast, right? Because once the information is received at leaf 5, it knows that this particular information or MAC 1111, it resides behind 333. And also leaf 5 received a unicast reply from host 5. That is why leaf 5 is directly sending the traffic to leaf 3. And now you can see that in the destination source and destination IPs, these are simple layer 3 device logic, that the MAC addresses are the interface MAC addresses. You can see that 0011 is the source MAC and the destination MAC is 3131. You can see here, simple. Also, if you see the capture that we have done only 5 also, if I go up and if I look for, this is the broadcast, right? Everything will be same. The only thing that I wanted to show you is this one is the source MAC, and the in the outer layer 2 header we have the source MAC as 0013, which is the interface MAC address of spine 1 0013, and the destination MAC will be same. You can see that because the destination IP is the multicast IP, so that is why the destination MAC is unchanged. It is also the multicast MAC. Okay. So this is how we can leverage multicast. Now you can see that we did not do any complex configuration into the multicast, right? And like in BGP, EVPN, just to make it possible for the host so that they can communicate into same subnet, we have done a lot of configuration for BGP, EVPN, right? But here you can see that minimal configuration we had done. Maximum 5 to 6 commands we have done, and everything is working perfectly. So this is how multicast can be configured to achieve the intra subnet communication. Okay. So before we close today's session, we can also verify the MAC address table. Maybe now you can see it is learning about host 5, and who is the originator of this information. It is leaf 5, and we are using the NVE interface. Same configuration you can check on leaf 5. Can see that we are learning about 11111 with the help of leaf 3. Also, you can see if you run this command, show NVE you can see that we have the multicast group that we are using for the NVI. So this was all about multicast or intra-subnet communication using multicast. In our next section, we will discuss about the inter-subnet communication. I hope that you are more comfortable now into the intra-subnet communication. We have discussed about the ingress replication, or you can say the static ingress replication. We discussed about the dynamic ingress replication, and now we discussed about the multicast into underlay, okay, to achieve the intra-subnet communication. Also using the Wireshark, I have shown you the packet flow, but what we can do in our next section, we will do only the packet walk for multicast, and then we will do the inter-subnet communication configuration and theory part. Okay. Okay, then see you in the next section. Thanks for watching.